This video is for activity 1.1.3C gears for principles of engineering. So the main lesson objective, at the end of this lesson, students should be able to calculate gear ratios for multiple gear trains and compound machines and differentiate how torque and force are applied in a compound machine. So let's talk about gear ratios with multiple gears. So in this example right here, we're going to say that gear A is going to be our driver gear or our input gear to start out with. So now what we want to do is we actually want to find out what the gear ratio is between gear A and gear B. So we know that the gear ratio has to be the number of teeth out over the number of teeth in. So in this example, it's going to be 12 over 20. So 12 is the in, 20 is the out. When I divide that out, I get 0.6 over 1. What's the gear ratio between B and C? So again, the same kind of thing. This time, though, the B gear will be our in gear, and then our output will be the 5-tooth or the red gear. Okay, so we get 5 over 12, and when we factor that out, we get 0.42 over 1. And what's the gear ratio between C and D? So again, input, output, we put that 20 over 5, and we get a 4-to-1. So if we look at this a little bit closer, if we have all of our gear ratios together side by side, remember, in order to find the total gear ratio of all the gears in the system, we're going to simply find the product of all of those gear ratios. So when we multiply this out, we do get 1 over 1. We get slightly 1 over 1 for the top part, but we're pretty close to 1, so we're going to say that it's just 1-to-1. If gears A and D were directly connected to one another, what would the resulting gear ratio be? Well, we know that this gear would be the input, this would be the output, and so we'd have 20 over 20, and again, you can see that we're also left with 1 over 1. So the idler gears don't affect the gear ratio, okay? If the last gear had 40 teeth, what would be the total gear ratio? Well, again, we would go ahead and factor that into our equation. Instead of this being a 4-to-1, it would be an 8-to-1, and so now we would get a 2-to-1 gear ratio, okay? Again, you can kind of see that we get the same kind of thing if we have, if we were to multiply all three out, we would get a 2-to-1, but if we were to simply just have our output gear be 40 over 20, we would still get the same gear ratio. But there's actually another way to do it too, and so let's kind of talk about this here for a second. So the gear ratio out over the gear ratio in, what's A to B? Well, we know it's going to be 12 over 20. B over C is going to be 5 over 12, and C over D will be 20 over 5. So what I can do is I can actually cancel out all of the like values and be left with some gear ratios for my input and output gear. So I know my 12s will cancel out and my 5s will also cancel out, and I'm left with a 20 over 20, which is also, again, a 1-to-1 gear ratio. Gear ratios are similar to mechanical advantage, and gear ratios apply to torque instead of force. So you want to make sure that you don't get those two confused, okay? So force out would be equal to your mechanical advantage times your force in, or your torque out is equal to your gear ratio times your torque in. In a compound machine, the total MA and GR are products of the components, so we can only multiply our mechanical advantages, and we can only multiply our gear ratios, but we can't combine those two to figure out, you know, the total mechanical advantage and gear ratio together. So again, mechanical advantage is only used to calculate forces and not torque, and gear ratio is used only to calculate torques and not forces. So let's actually look at an example of a compound machine. So when designing a compound machine, each mechanism is either a simple machine or a powertrain element. And so we have the 6 simple machines, which are lever, wheel and axle, pulley, inclined plane, wedge and screw, and those contribute to mechanical advantage, but not gear ratio. And the 3 powertrain elements, which are gears, a belt and pulley system, or a chain and sprocket system, contribute to gear ratio, but not to mechanical advantage, okay? So let's kind of look at this a little bit further. So here we have 3 mechanisms in series. We have a wheel and axle. And so again, we know that this black bar is going to spin 360 degrees. And we know that we have this black bar attached to an axle. Well, you might think that this is the axle, but this purple gear is really the axle because this is what's doing the work, okay? And it's doing the work because it's also attached to another gear. Since we have these 2 gears connected together, we have what's called a gear train. And then finally, we're left with another wheel and axle. Again, this being the wheel, and then this blue gear being the axle, because again, we're taking into account the teeth that are in this example, because that's going to be doing the work. So let's look at the mechanism for the wheel and axle for the first one. So our mechanical advantage is dE over dr. Okay, so the distance of the effort force divided by the distance of the resistance force. We know that this arm right here, the radius, is going to be 4 inches. And we know that the radius of this gear, because this gear is what's doing the work, is also 1.5. So when we divide that out, we're left with 2.67. Remember, mechanical advantage is used to calculate forces, and gear ratios are only used to calculate torque. So here we've calculated mechanical advantage for our wheel and axle, our simple machine. Now, if we look at the second one, the gear train, the gear ratio is equal to the number of teeth out over in. We know that the in gear is smaller, so it has less teeth, so it has 24 teeth. And then the output gear has 60 teeth right here. And so when we divide that out, we get a gear ratio of 0.4. And then lastly, when we look at the final part of our compound machine, we have an arm here. So we have a radius. This is going to be the radius of our wheel, just like we had at the very beginning. And it's connected to the axle, which is going to be this blue gear here. And so we know that the distance of this resistance force is going to be 4 inches, and we know that the diameter of this smaller gear is going to be 0.6. So when we divide that out, we get a 0.15. So to find our total mechanical advantage, we're only going to incorporate the wheel and axle assembly here at the beginning and at the end. So we multiply those two, and we get 0.4. And the total gear ratio, well, we only had one set of gears in here, so our gear ratio is simply going to be 0.4. Compound gear train. So this would be an example of a compound gear train. We have multiple gears that are part of this system, and you can see that we have some stacked on top of other gears. So we'll talk about why we want to do that here. So let's look at this example. So we have a driver gear, and so this driver gear is going to be spinning, and it's going to be hooked up to this yellow gear. So the green gear is driving the yellow gear. But then we're also going to have this blue gear tied in with the yellow gear, which is then going to spin this red gear. So the 2 middle gears share a common axle, so they rotate at the same speed. And so the reason why we do this is that it allows the final gear to rotate slower and produce more torque than if it was directly connected to the driver gear. So if we had the red gear connected right to the green gear, we could actually get less torque out of that, but we want more. So we're going to incorporate this gear system here in order to give us more torque. And so we can get more torque in kind of a smaller area. We can kind of stack these things up on each other and give us more bang for our buck, so to speak. So then what is the gear ratio between gears A and B? So the gear ratio is out over in, so we have 40/10, which is 4:1. What's the gear ratio between C and D? Well, again, that's going to be 50 over 20, and so we get a gear ratio of 2.5 to 1. So what is the gear ratio of the entire gear train? Well, again, we're going to multiply that out, and 4 times 2.5 is equal to 10. So we get a 10 to 1 gear ratio. What about a belt and pulley system? Well, here's an example of a belt and pulley system found on a vehicle. You may have seen this in your own car where you've got a belt kind of snaking its way through a bunch of different pulleys to kind of make a bunch of different things happen. So here's some equations that you can write down that still apply to the belt and pulley system. So we know that we have diameter out over in, we have RPMs, and then we also have torque. And so in this example, our diameter would be 6 inches, diameter for the smaller would be 2. Same way with our revolutions, 30 over 10, and then our torque would be 55 and 18 1/3. And when we cancel out our units, we're still left with the same gear ratio of 3 to 1. Chain and sprocket and chain systems. So a good example of that would probably be a bike. This is the one that you're probably most familiar with. You'll probably have a larger sprocket at the front with a chain that wraps around the cassette on the back part of the bike, which has smaller gears that kind of help change the amount of work you have to do to get it to pedal down the road or down the trail. So again, we have number of teeth out over in, that's on the sprocket itself. Diameter we can still use, RPMs we can still use, and torque we can still use. So again, in this example, number of teeth out over in, 22 over 11, 3 by 1.5, 90 over 45, and the torque would be 120 over 60. And so you can still see that we're still left with the same gear ratio. There are some advantages and disadvantages of both the pulley and sprocket system. Method of transmitting force is the belt by a pulley and the chain by a sprocket. Advantages for pulleys is quiet, no lubrication needed, and it's inexpensive. The disadvantage is that it can slip. A sprocket, there's no slip, but has greater strength. Higher cost, also needs lubrication because you're incorporating a chain, and it can be a little bit louder. That does it for this lesson. Make sure that you submit your guided notes, complete your mastery check, and then move on to the next lesson when the mastery check has been completed. All right, good luck.